Hello, chemistry students. I'm going to be going ahead and I'm going to be sharing with you guys a few things on it, and also to go ahead and go over a few things with you, so that we're going over them before the unit exam. Whoops. So those are a couple of things that we are going to go ahead and to go over. We're going to go ahead and we're going to talk about a few things that are on here. We're going to talk about the study guide and then a couple of tips and tricks as we are getting into our Unit 1 test, okay? So here are the first few things. So the first thing that they ask us is, what is the difference between mass and volume, right? So the mass is going to be pretty much how much it goes ahead and how much it weighs, in a sense. There's a more technical definition, but we're not going to go ahead and we're not going to go into that at this time. And then for the volume, our volume is how much space it takes up. Okay, so our volume is how much space it goes ahead and how much space it goes ahead and takes up. So those are our different things on there. So those are our two things that you guys have to know. Okay, so moving on. So this is going to be pretty much our states of matter sort of deal. So you have to remember that there's 3 states of matter that we focused on. We focused on solids, liquids, and gases. And so going ahead and focusing on this, right, they want to go ahead and we're going to represent these atoms that are currently liquid in a solid. So this is going to be liquid, and then this one's going to be solid, right? So we want to go ahead and we want to look at those two. And if you guys are looking at this, right, solids are very, very tightly packed together. So if you guys have something drawn in there that looks something like this, right, that is how you guys would go ahead and how you would represent a solid, right? This again is going to be liquid, right? And we're going to go ahead and we're going to represent these atoms in a gaseous phase, right? So if they are a gas, what you guys see is that these atoms are more spread out and they are moving in very quickly in all different types of directions, right? So all of these gaseous atoms are going ahead and they're moving quickly, right? So one of the main things that I want to point out is that as you guys are increasing temperature, right? So as there's an increase in temperature, right, you guys will see that you guys are going from solids to liquids to gases, right? So as we're increasing the temperature, you guys will see that we change from solids to liquids to gases. So for example, when we're talking about ice, right, we start talking about our solid ice, and then our solid ice gets warmed up, and then it will go ahead and it'll be liquid. And then after it's liquid, right, and if you keep on warming it up and keep on warming it up, then it'll eventually turn into steam, which is a gas. Okay, so this one, it says the box to the left contains iron in steel wool. So this is from the change of mass experiment. Represent the atomic structure of this, right, after we go ahead and after we go through strong heating. So if we go ahead and if we heat up these atoms, right, some of the things that you guys should see is that you guys might see the atoms start to spread out a little, but not too much, right? So for this one, the main thing is that your atoms, they go ahead and they start to spread. So these things go ahead and they start spreading out a little bit. They don't really go into a liquid phase, but the atoms are a little bit more spread out and they're not as clumped together when they're heating. Because again, you're getting closer and closer to the liquid, right? You're not at the liquid, but you're getting closer to it. Okay. So, I'm gonna show you guys a couple of things on here. So I want you guys to go ahead and to kind of focus on this, right? So this is gonna be a chart, and you guys are gonna be looking at this chart instead of a histogram. So this one mainly is chart instead of histogram. And in this chart, you guys are going to see a mass change. So this means that if you guys see a plus sign, it means that it gained a mass, right? This means that we lost mass, right? So it's overall pretty simple to read. So you'll see that groups 1 gained mass, but groups 3 to 5 lost mass, right? So it says that the 7th period chemistry class produced a chart. We're going to say chart. Below for change in mass when sugar is dissolved in water, right? They concluded the mass decreases slightly when the sugar dissolves because they go ahead and they see this, right? Provide a better explanation. So what I mean is that we have to go ahead and we have to use our knowledge of conservation of mass. So in conservation of mass, we go ahead and we see the following. Conservation of mass basically says that mass cannot be created or destroyed. So mass cannot be created or destroyed. I think it's a Y. So when we're talking about mass cannot be created or destroyed, what we're basically saying is that mass is not just going to disappear. So we have to go ahead and we have to provide an explanation on why we go ahead and why we see a change of mass when we're putting sugar into water and we're dissolving it, right? So in this case, we're looking at lab errors. So where are ways that people can go ahead and where they can screw up, right? So depending on your procedure, right, you probably measured out the mass of sugar, and you probably did not get all of the sugar, all sugar into a beaker, right? So for that one, right, you might have not gotten all of your sugar into that solution. So therefore, you might have just gone ahead and you guys might have seen that. And if you guys will see, it's 0.01 of a gram, so it's a very, very small amount. So likely that could have been like some sugar dropped somewhere, somehow, right, that they didn't get into there. But either way, the mass should not change. So those are the things that we should see. Okay, so I'm going to go over this mass and volume graph because you guys are going to see a graph like this. You guys won't have to write an equation for the line, but I want you guys to be able to kind of interpret the graph and know what this graph is going ahead and this graph is stating. So we have our mass here and we have our volume here, right? So those are our two things on there. If you guys were to go ahead and if you guys were to do this, so just for the sake of the equation of the line, you guys go E equals Y equals MX plus B, right? So your y-intercept is negative 0.420, right, X, and then your slope is 0.90 is equal to y. So pretty simple because this is the m for the slope and that is the b, and those are the things that end up there. Okay, so in looking at this graph, what you guys will see is that we have mass and we have volume, and we're relating the two with each other, right? So every time the mass goes up, you guys will see that the volume goes up as well. Right, so the mass goes up, the volume goes up. So as the volume increases, as the volume is increasing, right, the mass is also increasing. So those are your things that you guys see on there. We're going to talk about next about the slope and all of that. But I am going to go ahead and I'm going to pause this and then we'll conclude.